In cycloidal curves, first of all, we have to classify the cycloidal curves. There are three types of cycloidal curves are we have to study: cycloid, epicycloid, and hypocycloid. In cycloid, if you change the position of point inside and outside of the circle, you will get another two curves: inferior trochoid and superior trochoid. Same thing in epicycloid for inferior trochoid and superior trochoid, and for hypocycloid, if you select the point outside and inside, then you will get inferior hypotrochoid and superior hypotrochoid. Now, what is cycloid? It is a locus of point on the circumference of the rolling circle, which is known as generator, which rolls without slipping or sliding along a fixed straight line. It is called direct. So if you take a circle and roll on a straight path, the point on the circumference of the circle trace the curve. That curve is known as cycloid. Here in this picture, you can see the cycloid for one revolution of the circle. If we extend the circle for another revolution, you will get the another cycloid. Now let us see one example for cycloid. A wheel of a circle of a diameter 50 mm rolls over the straight line for one rotation. Draw the path traced by the point P, which is initially at a point of contact between the wheel and the straight line. Draw normal and tangent at any point on the curve. So given data in which the diameter of the circle is 50 mm, so the radius 25 mm, and length of the director means the circle rolls on the straight path, and when the circle complete one revolutions, it travels 2 pi r distance on the straight path. So 2 pi r means here distance 157 mm. So first of all, you have to draw one circle by taking radius 25 mm. Draw vertical and horizontal line from center of the circle. Then draw the horizontal line from bottom of the vertical line of the circle, which is known as director. The length of this line is equal to AB 2 pi r 157 mm. Divide the circle into n number of equal parts. So I divide the circle into 4 number of equal parts. Divide the straight line AB into 8 number of equal parts. Now we want to roll the circle in clockwise direction. The number on the periphery of the circle will be anti-clockwise. 1, 2, 3, 4, 5, 6, 7 and 8. Now we have to draw a horizontal line from one point which is on the periphery of the circle. So this horizontal line must be parallel to AB. Also from 2, 3, 4, 5, 6 and 7. Here for point number 3 and 5 there is a single line. Point for 2 and 6 also single line. Point 1 and 7 has a single horizontal line. Now from points on the horizontal line 1, 2, 3, 4, 5, 6, from all points we have to draw the vertical line up to this line. This is known as center line because which is passing from the center of the circle. And give the name of the points C0, C1, C2, C3, C4 up to C8. C0 is a point which is the initial position of the circle, center of starting of the circle, When the circle rolls 45 degree, then the center of the circle will be C1. Similarly, for next 45 degree, center of the circle will be C2. And after one revolution, the center of the circle will be C8. Now, actually, in cycloid, we want to find out the loci of a point P0, which is point on the circumference of the circle, and P0 is 25 mm away from center of the circle. So this is a starting point of the circle. Now when we roll 45 degree, the center of the circle C1 and P point goes on this horizontal line which is passing from 1. So how to obtain the point P on this horizontal line? So for that you have to take center C1, 25 mm radius, and draw arc on this horizontal line which is passing from 1. And that intersection of arc and horizontal line is point of cycloid. Another point, by taking center C2, radius 25, draw arc on horizontal line which is passing from 2. From center 3, similarly for center C3, C4, C5, C6 and C7 and last C8. And in intersection points P1, P2, P3, P4, P5, P6, P7 and P8. Trace out the curve passing from all the points. So this curve is known as cycloid. Now how to draw the normal and tangent at any given point? Suppose you have to select any point on curve S. Now join S. Now draw arc by taking center S1, radius 25, and draw arc on center line which is T. Now from T draw vertical line up to horizontal line AB. That point is S1. Now join S1 and S with straight line. This line is normal and perpendicular tangent. So this is cycloid. Now inferior tropoid. It is a locus of point P inside the circumference of rolling circle which rolls without slipping or sliding along a fixed straight line. Example, draw locus of point 20 mm away from the center of circle which rolls on the straight path. Take diameter of the circle is 50 mm. So in previous problem we have a 50 mm diameter circle and we are taking the loci of the point P which is on the circumference of the circle which is 25 mm away from center. But in this case we have to draw the locus of point which is 20 mm away from center. Given data here, diameter 50, radius 25 mm, the circumference length 2 pi or 157. So first of all, draw one circle of 25 mm radius or 50 mm diameter, divide into 4 number of equal parts. Draw horizontal line pi d or 2 pi r which is 157 mm AB. Now P0 is 20 mm away from center C0. Draw one circle by taking 20 mm radius. Divide this circle into 8 number of equal parts and straight line which is 157 mm also into 8 number of equal parts. We want to roll the circle clockwise. So numbering on the smaller circle 1, 2, 3, 4, 5 anti-clockwise direction. Draw the horizontal line from every point 1, 2, 3, 4, 5, 6, 7, 8 and also from center C0 and vertical line from 1, 2, 3, 4 which is on line AB and find out the intersection of the center line and vertical line C1, C2, C3, C4 up to C8. Now in this case, for infrared trochoid, we have to draw the loci of this point P0, which is not at the circumference of the circle but inside the circle. So here, for one rotation of the circle, the number of position of P will be find out by taking radius 20 mm and center C1 and draw arc on the horizontal line which is passing from 1, and that point is P1. Similarly, C2 center 20 mm radius, draw arc on line 2. C3 center 20 mm radius, arc on line number 3, for line number 4, line number 5, 6, 7 and last 8. Draw all the points of intersection and trace the curve passing from all the points P0, P1, P2 up to P8. So this curve is known as inferior trochoid. Now for superior trochoid, it is a locus of point P outside of the circumference of the rolling circle generator, which rolls without slipping or sliding along a fixed straight line or direct. Now take one example. Draw a locus of point which is 30 mm away from the center of circle, which rolls on straight path. Take diameter of the circle is 50 mm. So given data in which we have given diameter of the circle or radius. So length of the circumference 2 pi r 157 mm, and the radius for arc to obtain the superior circle is 30 mm. Draw one circle by taking 25 mm radius, the director 157 mm. Draw another circle which is of radius 30 mm. So we have to take the initial point P0 on this circle which has radius 30 mm and divide the circle into 8 number of equal parts, and the horizontal line is also divided into 8 number of equal parts. For clockwise rotation, numbering will be anti-clockwise, and draw the horizontal lines from every points on the outer circle. Draw the vertical line from directors to obtain the center points C1, C2, C3, C4, C5, C6, C7 and C8. Now to obtain the points of the curve, we have to take radius 30 mm C1 center and draw arc on the horizontal line which is passing from one of the outer circle. Similarly, center C2 30 mm radius, draw arc on line number 2. Center C3 30 mm radius, arc. Center C4 radius 30 mm. Center C5 radius 30 mm, draw arc on L5 for L6 and L7. Last L8. Which are the points intersections P0, P1, P2, P3, P4, P up to P8. Trace the curve from all the points. We will get the superior trochoid. Thank you very much for watching this video.